Okay, question 32. So determine the x-coordinate of the mass center of the portion of the spherical shell of uniform but small thickness. So assume that we have a eggshell, for example, eggshell, and it has a thickness and it is uniform everywhere. So we need to decompose this to some differential elements first. So assume that this is the element and this is the center of that sphere. So from the center of the sphere to here is r, and because this is d theta, the angle, therefore this arc will be r d theta. So the mass of this differential element is rho dv, actually not dA, but we just assume that there is t here and t is 1 unit. You might tell me, okay, 1 unit is cannot be a small, but anyway, if you don't want to consider it as 1, you can just type or write here t, rho t dA. So how much is the circumferential of this shell? It's 2 pi y. And how much is this arc? It's r d theta. And we also have a shell thickness, which is t. So that will be the volume. And this will be the result, 2 pi y. And instead of y, I will just sub r sine theta. Therefore, the final dm will be 2 pi rho r squared sine theta d theta, and if you like, and it is much better to also put t here, which is thickness. So m is the integration over dm, and therefore m will be integration from 0 to cos inverse 1 over 4. So you need to, for finding the limit, the theta, let me show you something. So here is r over 4 from here to here. And this point, y is 0 and the x is equal to r. So if someone asks you, the theta is, okay, you might ask me, okay, theta is coming from the x or coming from the y? It's coming from the x because theta is here. So theta at this point is 0. What about here? Look at here. If this differential element is at these points, this length is r over 4, and this is r, the radius. Therefore, cos theta will be r over 4 divided by 4, which is 1 over 4. Therefore, theta will be arc cosine 1 over 4. This is very important. And what 2 pi rho r squared, everything can come out of the integral. Therefore, integration of sine will be minus cosine from 0 to cos minus 1 over 4, which will be this. Because when you put cos inverse here, it will cos inverse will be 1 over 4, and 0, it will be minus 1. So the full answer will be, the total will be this ones. So if you want to find the x bar for this shell element, the x bar is x, or r cos theta here. Okay, r cos theta times dm that we obtained before, 2 pi rho r squared sine theta d theta. Integration of this over from the limit of 0 to here, which was the arc cosine 1 over 4. And again, we obtain this, and we have here sine and cosine. Multiplication of this will be sine 2 theta over 2. Okay, and the 2 and this 2 will be cancel each other. So integration of sine will be minus cosine again divided by 2. And you can substitute this again. This one is a little tricky. Cos 2 theta cosine minus 1 over 4. I will give you a hint. There is a formula for this one. 2 cos square theta minus 1. You can use that formula to make sure that cos minus 1, cos inverse will be theta. So the final answer will be this, and then you will find the x bar. Okay, if you didn't understand this part, I will show you something now. I want to show you how this angle works actually. Then we will go to the feature, revolve these ones, easy, yeah? So remember, this is the shell we have, and this is the thickness. It should be very low, actually, from here to here, okay? And RD theta is from here to here, okay? And the circumferential is like a circle, yeah? 2 pi y. That's it. Okay. Also, I will show you the formula. Here I show you the cos 2 theta formula. Here we will use the second one, okay? For finding the, instead of cos 2 theta, let's put 2 cos squared theta minus 1 and just sub cos inverse 1 over 4.